Okay, class, now that we've created our data strip, I've taken it and taped it down to the table, as you can see, on both ends, stretched out nice and straight. And I've placed a meter stick along the dots that were created. Let me see if I can get close enough. There we go. Okay, now you should be able to see the little blue dots that were made by the carbon paper on top of the strip as it was pulled through. Notice that as it goes along, those dots get further and further apart. That's because as the mass fell, it accelerated. It went faster each second than the previous second, which means it covers more distance as it falls each second. So the dots get further apart. Now, on your handout, you have a little picture that's not complete. You may want to pause it right here and complete this little picture to help you. Okay? What we're going to do now is we're going to measure the location of each dot from the beginning. In other words, where was the mass as it fell? So, I have put the 1.0 centimeter mark on dot 0. And we are not using every dot. We're skipping every third dot. That just cuts down on the amount of data that we have to deal with. So we'll be finding the average acceleration for each interval. Now, what amount of time is each interval? Well, that spark timer makes a spark every 1/60th of a second. So the time to go from one dot to the very next dot is 1/60th. So if we're skipping to every third dot, that means from dot 0 to dot 1 was 1/60th of a second. From dot 1 to dot 2 was 3/60ths, because you're skipping spaces. So 1, 2, 3/60ths here, 1, 2, 3/60ths there. So from each of our measured dots to the next is going to be 3/60ths or 1/20th of a second. Now on your data table, that means dot 0 was made at 0/60ths, dot 1 was made at 3/60ths, dot 2 at 6/60ths, dot 3 was made at 9/60ths of a second, dot 4 at 12/60ths, and so on as the mass fell. Now we need to get the position of each dot from 0 as it fell. So please notice that I have placed not the end of the ruler, but the 1.0 centimeter mark right on dot 0. That's because if you'll look, the end of the ruler is really messed up. Would dot 0 really be on 0 centimeters if I use the end of the ruler? We don't know, so it's best not to use it. So that means on all the positions that we're going to measure, subtract 1 from the number that you see. So right there, dot 0 is at 1.0 centimeters, so subtract 1, it's at 0.0 centimeters. So that is the position of dot 0 is 0 centimeters. Now, dot 1, let's see if I can get it to focus better. Just doesn't want to sometimes. That's better. A little better. There we go. That's beautiful. Dot 1 would be at 1.45 centimeters. You can pause it and look. So subtract 1, that means dot 1 is at 0.45 centimeters. Now I'm going to go along and show you each dot, and you take a reading, okay? But wait until I sort of pause it, or hover over it before you pause it and get a clear reading, okay? I've got to get the camera right above it. The camera's not in the middle of the tablet, it's at the end, so I have to be careful what I'm doing. All right, so we've already got dot 0 and dot 1. Here is dot 2. Take a measurement. dot 3, I'm getting it right over the camera, or right under the camera. There's dot 3. Skip 2, there's the third, so dot 4. Skip 2 dots, there's the third, dot 5. I'm sorry I'm shaking so bad, guys. Okay, and skip 2 and dot 6. Look how much further apart they've gotten. Okay, and dot 7. And dot 8. And you can always pause it and look at the measurement. Okay. Now, so what you're going to do is write those positions right here on this column. The position of each dot, and there should be a little vector symbol on that, the position of each dot as it was made, as it fell in time. So here's the time of each dot: 0, 3, 6, 9, 12, 15, 18, 21, 24, 60ths of a second. The change in time from one dot to the next, because remember, velocity is the change in position divided by the change in time, the time interval. So the change in time from one dot to the next would be 3/60ths of a second. Now how do we do this? Everybody put zeros across through here, because that's going to be 0 for dot 0 every time. But down here I've got the little formulas that you're going to use. Okay, and you're going to follow those patterns to fill in this chart. Okay, make sure you put a sample calculation right here for each one. For example, pick a trial. Maybe trial 2. Okay, you pick trial 2 and you're going to show me how you got the change in time, the change in position, the velocity, which is the change in position over time, the change in velocity, and the acceleration, g, due to gravity. Then you're going to average all your accelerations at the end and put it right there. That's what you're doing for today. We'll worry about method 2 tomorrow. Method 2 is going to be a graphical method. Okay? All right. Thanks, guys.